So, I don't know. So for the first one here, we'll discuss these together. 5 times the difference of a number and 7. So the question is, obviously we have multiplication and difference means subtraction. Which one has to happen first here? The x minus 7. Yeah, the difference. Because it's 5 times the difference, not 5 times the number. So the subtraction has to happen first. So we need parentheses around the x minus 7 and then times 5. Now this next one is kind of tricky because the wording seems weird. I have the product of 8 and a number increased by 3. So the product is saying we're multiplying two things. But what we're multiplying is not 8 times a number, it's 8 and a number increased by 3. Or is it 8 and a number, the product of 8 and the number, and then it's increased by 3? Did anybody do it one way or the other? This one's ambiguous. There's really no way, there's no way to tell by the way this is worded which one that is. The left one? This one? Yeah. This one I would have to have accepted either way because the way that's worded, you cannot tell whether the increased by 3 goes with the number or if the increased by 3 happens after the product. Okay, so that's kind of one of the big things we did at last class was deal with translating that English into symbols and numbers. And there's the next step that can come out of that. And that was, things like this. A number increased by 7 is 12. So this is not just an expression. It's not just giving us that algebraic number. It's adding something more to it. The is here is kind of splitting up this phrase. On this side, a number increased by 7 is simply, what is it? A number increased by 7? X plus 7. Perfect. Is means equals 12. So we're adding that next step of having an equation there. Or we might have 3 more than 7 times a number. Is 5 less than 8 times the number. So this one's getting a little more complicated. But again, we have the is here that splits this up. That is the equal sign. So what comes before it? Perfect. 3 more then means 3 is being added to something. 7 times the number is 7x or 7n or whatever. So 7x plus 3 equals 5 less than 8 times the number. 8x minus 5. Very good. 5 less than means 5 is subtracted from something. 8 times the number is 8x. Excuse me. We're going to come back to that skill more as the day goes on because we're going to have to start interpreting word problems. As we go through the course, we are going to start sliding more and more to word problems and applied problems like that because unfortunately the world is a word problem. The world doesn't ever come to you and say, what is 3x plus 7 equals 19? Find x or whatever. But what we are going to look at next is going to be this type of an arrangement. X equals 4. This, of course, is an equation. And the meaning of it all rotates around this symbol, which, of course, is the equal sign. Right? So here's the tough question. What does that symbol mean? It's hard to define it without using the word equals, isn't it? What it means is what's on one side of that symbol has exactly the same value as what's on the other side. So x and 4 have exactly the same value. In fact, we can think of it like a scale that is perfectly balanced. What's on one side of the scale is exactly the same, has exactly the same weight or mass as what's on the other side. Now, all equations start out in this form, as a variable equals a number. And they are built up from there. How are they built up? Well, we can use any one of our basic operations. We've got add, subtract, multiply, divide, and we even have powers and roots that we can use eventually to build these up. So let's take a look at doing something simple like adding 7. So I add 7 to the x. I'm building up this equation. That's now x plus 7. Now the problem is if I add 7 over there, this scale is going to tip unless I do what? The exact same thing to the other side. I have to add 7 to the other side. By adding 7, by doing the exact same thing to both sides of the equation, I'm making sure that scale stays balanced. So here's my equal sign. Bless you. 4 plus 7 is 11. Now I've built onto that equation. I've built it up to be more complex. Well, what we're going to see most of the time is this command, solve. And what that command, what that request is telling us to do is to take this apart. Now in this case, we watched the equation get built. We built the equation, so we know how it was built. It was built by adding 7. Well, how would you take that apart? How would you remove that adding 7? Subtract 7. Very good. And you're exactly right. If I subtract 7 from one side, I have to do the exact same thing to the other side to keep it balanced. So I've removed the 7 over here, which leaves me with just x. To keep my scale balanced, I have to subtract 7 from the 11, which is 4. Which gets me back to where I started. And that's what solving an equation is asking us to do, is to take it apart and get back to that original form that's a variable equals a number. Now, as I said, this equation we built. So we knew how it was built. We knew how to take it apart. The key to solving equations is figuring out how they are built. So if I have an equation like y minus 9, well, let's do 4 is equal to y minus 9. To figure out how it was built, the first step we need to do is find the equal sign. Well, the equal sign is right there. Second thing we have to do, find out which side the variable is on. Well, that's this side right here. There's our y. Now that we've done that, we have to ask ourselves, what is keeping the variable from being alone? In other words, what's keeping the variable from being by itself on that side of the equation? Well, here it's the 9. And the final question, how is it attached? Or what operation was used to build it on? So here, that 9 was, what operation was used to build the 9 onto my y? It was subtracted. So how am I going to get rid of it? Add it. So I add 9, makes that 9 go away. So all that's left over here is y. Now what do I have to make sure I remember to do? Add 9 to the other side to keep my scale balanced. 4 plus 9 is 13. And there we are. We are to that form of a variable equals a number, or a number equals a variable. Now I can always check my answer to see if it works. I'm not going to require you to do this, but it's a good idea to do it. And some of the questions in my math lab do ask you to go back and plug it in. So if I'm saying that 13 is equal to y, or y is equal to 13, that means I can come up here and replace y in that equation with the number 13. So instead of 4 equals y minus 9, I can put in 4 equals 13 minus 9. And now I have to check to see if I get the exact same value on each side of the equal sign. Obviously, there's nothing to do with the 4. 13 minus 9 is also 4. So I do have the same value on both sides. So that is telling me that that is the correct answer. I won't make you write it out like this. I'll just make you solve the equation. I'm just going through all the long steps just to help people through the thought process. So we might have 7z equals 21. So again, I'm going to find the equal sign right here. And I'm going to identify which side has the variable on it. In this case, it's on the left side. What is keeping my variable from being alone? The 7. What operation is used to attach the 7? Well, it was multiplied. So to get rid of it, we have to divide. Yeah. So we're going to divide by 7 because the variable was multiplied by 7 to build the equation. We divide by 7 to get rid of it. So that's leaves with just z there. And you're right. We have to divide both sides to keep that scale balanced, keep the equation balanced. 21 divided by 7 is 3. Now again, if you wanted to be sure, you could double check it. 7 times z is going to become 7 times 3 and see if that equals 21. Well, 7 times 3 is 21. So we do have the same value on each side. Now our equations do not stay this simple. We could run into 3x minus 5 equals 16. The process, however, does not change. We find our equal sign and we identify where our variable is. So it's over there on the left. So now we ask ourselves, what's keeping the variable from being alone? Well, there's two things now. We have the 3 and we have the 5. What operation was used to attach the 3? It was multiplied. And the 5 was subtracted. So if we ask ourselves here, what was done to our variable? What was done to x? Order of operations says which would happen first? Would you multiply first or would you subtract first? You would multiply. So when this equation was built, the first thing that happened is the variable was multiplied by 5. And then, or not multiplied by 5, sorry, multiplied by 3. The variable is multiplied by 3. And then 5 was subtracted from it. Now, if we go to take something apart, which when we go to solve it, that's what we're doing, is taking the equation apart. Let's say you just finished putting something together. Maybe it's a piece of furniture or toy for your kids or whatever it is. If you've just finished putting it together, you just put on the last piece. If you go to take it apart, what's going to be the first piece you take off? The last piece you put on. The last piece put on here was the subtracting 5. That's going to have to be the first piece we take off. And we're going to take it off by adding 5. And we're going to have to do it to both sides, correct? So we add 5, makes the negative 5, the subtracting 5 go away. Leaves us with 3x there. 16 plus 5 is 21. Now what? X has been multiplied by 3, so we have to divide by 3 to get x by itself. We divide by 3 on the other side to keep that scale balanced. 21 divided by 3 is 7. Any questions? Now, I realize for a lot of you, you don't have to go through this thought process. I'm just pointing it out so that you see the thought process behind it, and you see why it is we do that. A lot of you have been taught something called reverse order of operations. Basically what they're saying is you do the order of operations backwards when you solve equations. Well, that's partially true, but not totally true. It's partially true because addition, you would do your adding and subtracting before you multiply or divide when you're solving the equation. But parentheses are still going to have something done first when we get parentheses into our equations. The reason that we have that appearance of reversing the order of operations is because of what I just said right here. When you take something apart, you have to take off the last piece first. So we do add and subtract before we multiply and divide. Let's do one more example, and then we'll have you try a couple. So let's say that 19 is equal to 2y plus 9. What do we have to do first to solve that equation? Subtract 9. Good. This equation was built, y was multiplied by 2, and then 9 was added to it. So to reverse that, we subtract the 9, makes that go away. We're left with 2y. Subtracting 9 over here leaves us with 10. And then divide by 2. Good. Takes that 2 away, leaves us with y. 10 divided by 2 is 5. So 5 equals y, or y equals 5. Now again, just like we did before, we can double check this. Replacing, if y equals 5, we can replace y with 5 up here. So instead of 2 times y, it's 2 times 5 plus 9. Now again, there's nothing to do with the 19. 2 times 5 is 10, plus 9 is 19. So we do have the same value on both sides. So we're relatively sure of that answer. In your notes, I'm going to have you try one quick. Solve that. What's the first thing we have to do? Add 2. Good. We add 2 to both sides, takes away the minus 2. 7z equals 33 plus 2 is 35. And then divide by 7. Good. So this takes away the 7, so we got z there. 35 divided by 7 is 5. Now at this point, I'm going to assume you guys know how to put it back in and check your answer, so I'm going to stop doing that. But that option is always there if you're not quite sure of what to do. Now, there are a lot more complex equations we can run into. We can run into, we'll go down a notch here. Something like this. Here we find our equal sign, and we identify where the variable is, bless you. And we see the variable appears twice. There's a 3x and a 5x. But if I'm thinking of that balanced scale still, both the 3x and the 5x are on the same side of the scale. So can we just push them together in one big pile? Would that change the balance of our equation at all? No, it wouldn't. We can go ahead and push them together. 3x and 5x make 8x. So we can turn this equation into 8x minus 2 equals 38. And now we would solve it by what we did before. What's our first step? Plus 2. So 8x equals 38 plus 2 is 40. And then divide by 8. So x equals 5. And again, you could double check it by putting 5 back in where the x's appeared in the original equation and seeing whether we got the same value on each side. Now, slightly different than that is an equation that looks like this. Looking at this one, 3x plus 7 equals 5x minus 9. We find our equal sign. We go to identify the variable, and we see the variable appears twice, but once on each side. We have 3x over here and 5x over here. Can I still push them together to make one big pile? Not really. They're on opposite sides. But I do still have to combine them somehow. To combine them, what I have to do is just basically get rid of one of them. And it's usually easier to get rid of the smallest one. And the only reason I say that is because it helps us to avoid working with as many negatives. So which one's smaller, 3x or 5x? 3x. So I'm going to get rid of the 3x. It's a positive 3x. So to get rid of it, I can either subtract or divide. But which one's going to completely get rid of it? Subtract. If I divide 3x by 3x, it's going to end up with 1. That's not totally getting rid of it. The only way to totally get rid of something is to subtract it. 3x minus 3x is 0. It's gone. Now I took 3, so all that's left over here is the 7. Now I took 3x off of this side. I have to do the same on the other side. Now on Monday we talked about operations with these algebraic numbers. When we add or subtract, we can only combine things that have the same name. So what can I subtract 3x from? 5x. 5x minus 3x is 2x. And I still have the minus 9, negative 9. Now this is an equation form that we know how to solve. What do we do first? Add 9 to both sides. So the negative 9 is gone. 2x is 7 plus 9 is 16. And then divide by 2. So that 2 is gone. We've got x here. 16 divided by 2 is 8. And again, we can come up here and replace x. So 3x becomes 3 times 8 plus 7 equals 5x becomes 5 times 8 minus 9. And we have to do our order of operations. Now I'm going to do each side. I'm going to do the left side first and then come back to the right. So 3 times 8 is 24. 24 plus 7 is 31. Over here, 5 times 8 is 40. 40 minus 9 is 31. So I do get the same value on each side, which is telling me there's a good chance that that is the correct answer. Now we're going to do a few word problems with these. One of the toughest things in math, I think, is taking a word problem and translating it into symbols, into an equation that can be solved. Even more difficult, I think, is taking these basic word problems and putting them into an equation. Mainly because the problems themselves, when you start out, are so simple, you can just look at it and say, here's the answer. So it's kind of tough sometimes to put the simple ones into an equation, because once you know the answer, it's hard to make your brain think about writing the equation. But let's do this. Let's say that Pete pays $7,824 in income tax. Pete's his total earnings are 4 times the tax. How much are his total earnings? Now here again, like I said, the problem itself is so simple. I mean, most people look at that and say, oh, I'm just going to take 7824 times 4. Right? But we want to write it out in an equation. So the first thing I'm going to do is I'm going to ignore the numbers in the problem and just look at the situation. Total earnings are 4 times the tax. And you don't have to use variables. You can write it out in words. Earnings is equal to 4 times the tax. It's that simple. Now we fill in the numbers that we know. Do we know the earnings? No. We know the tax. Bless you. So we put in the tax, the number 7,824 for the tax. So we're going to take 4 times that. 31,296. That is his total earnings. Let's say Sam gets 26 miles per gallon. How many gallons will it take for Sam to drive 598 miles? Now, here's a case where you don't actually need the problem, any information from the problem to write the equation. The equation is a standard formula. We know that your miles per gallon times your gallons of fuel used is equal to, the distance you can travel. So here, do we know the MPG? Yeah, 26 miles per gallon, right? Do we know the number of gallons? Yes, how many gallons? That's what we're looking for. So I'm going to just call that G. Start using a variable instead of a whole word. We better know the distance because we can only have one variable, right? Distance is 598. So now, how do we solve for G? Divide by 26 makes that go away. We divide the other side by 26 to keep it balanced. G equals 23. So it takes 23. Now, with these word problems, we do have to make sure we go back and answer the question. The answer here is not 23. The answer is 23 gallons. It's asking how many gallons. So let's say Pat works twice as many hours as Chris. How many hours does Chris work in a week? Bless you. Where Pat works 38 hours. So again, Pat works twice as many hours as Chris. That's our formula right there. So P equals 2 times Chris, so 2 times K. A lot of people struggle with these when they say 1 is twice. People want to multiply Pat by 2. It's not Pat that's multiplied by 2. Pat is twice as much as Chris. So it's Chris that has to be multiplied by 2 to get Pat's. So now, coming down here for the information we're given, bless you again. How many hours does Chris work? So we're asked to find the hours for Chris. We're asked to find K when Pat works 38. So that means P is 38. This is 2 times K. So we solve that by divide by 2. So 19 equals K. Maybe try this one in your notes quick. Find the Bi-monthly pay. Now, bi-monthly means twice a month, 2 times a month. For a job that has a, oh, what do I want to put in here? $55,200 annual salary. So find that bi-monthly pay quick. So here's another one where you look at it and you just say, oh, I take 55,200 divided by 24, because you know there's 24 pay periods in a year for bi-monthly pay. To write an equation for this, you would say that the annual salary is equal to 24 times each pay period, or each payment. So 55,200 equals 24 times P. We'll solve for P by dividing by 24, which is what, 2,300 bucks? And of course that's gross pay. That's before they take all the other stuff out. What's that? 24, since it's bi-monthly, that means it's twice a month. So 2 times a month, so 2 times 12 is 24. So it's 24 in a year. So then find the semi-weekly pay for a job with a oh, let's see here. $57,200 annual salary. So now bi-weekly means every 2 weeks. If we're assuming 52 weeks in a year, divided by 2, that is 26 pay periods in a year. So as you look at that one, how would we set this one up? Your annual salary is going to equal what? Perfect. 26. Yeah, times X or times whatever your pay is for each pay period. So we can put in here the 57,200 is our salary. Equals 26, and we'll just leave P as our variable for our pay. So to solve it, we're going to divide by 26. So our bi-weekly pay is $2,200 every 2 weeks. Now I do this problem for a reason, because there's something else I want to point out to you. Someone offered, if you have 2 job offers out there, one of them is offering you $2,300 semi-monthly. The other one's offering you $2,200 bi-weekly. What's that? I got those backwards, don't I? So we buy monthly and semi-weekly, shouldn't it? Bi-monthly, semi-weekly. It's the cold medicine talk. We'll blame it on that. Which one's a better paying job? I've actually had a close friend of mine, this has been a few years back now. left a really good job because it looked like he was going to get paid more. But it was going from he was getting paid semi-weekly and it went to bi-monthly. He actually took about $2,000 a year pay cut. So remember the numbers we had up here. This was 55,200 here. This was 57,200. So even though it's $100 a paycheck less, because there's 2 more paychecks in the year, it's still $2,000 a year more. Okay, we're at the point now where I don't want to start a new topic here. What we have left, I know a couple of you have said you can't make it in tomorrow. And what we're going to be looking at tomorrow is we're going to be reviewing. One is we're going to be reviewing operations with integers, the negative numbers. And 2, we're going to be reviewing the operations with the algebraic numbers again. So adding the variables, expressions with variables, adding, subtracting, multiplying, dividing again. Going through that review. Yes. If you're not here tomorrow, the lecture will be posted usually by the end of the day, but at the very latest by noon on Friday. There is a quiz, a new quiz, that starts today. It actually started, I think, at 8 a.m. and is due on Thursday, so that's tomorrow, by 11:59 p.m. That's actually quiz 2, so that will be on the same stuff that the homework was that you finished for Monday. So this, remember, the quizzes always trail the homework by 1. So the homework that you just finished from last class, that's what this quiz will be on.
Okay.
So I suggest you do the quiz first. And then there's going to be a new homework that's going to be due on Monday. And that is the homework that's on what we talked about today and what we'll talk about tomorrow as well.